Here I want to find the resultant force of these two vectors. So I'll set up my parallelogram by starting by drawing my 2 kilonewton force at that angle, and then drawing my 6 kilonewton force at that angle. And that's got to be 3 times longer than the other. And again, it doesn't have to be perfect, but the closer you get, the more realistic it will look. So then I draw these parallel lines, and I get my resultant force just like that. Okay, and what I'll do is, again, this is my resultant force, the diagonal of that parallelogram. This side is 2. This vector here is 6. And again, I know this side here is 105. Okay, and if you're not clear on how I know that, I can redraw kind of over here, right? This is 45. This is 60. I think it's a little easier to see over there, right? So 60 plus 45 gives me that 105. So now I can go ahead and again use the law of cosines to figure out that resultant vector, which is just going to be 2 squared plus 6 squared minus 2 times 2 times 6 times the cosine of 105. Again, make sure your calculator is in degrees and you get a resultant force of 6.80. Okay. Now that I know that that's 6.80, I can go ahead and find the angle. I'm going to find this angle right here, right? So I'm going to use the sine of that angle divided by the side that's opposite, which is 6, and set that equal to my known angle, which is 105, divided by what's opposite, which is what I just found, the 6.8. And again, you're going to want to use in your calculator all of the decimal points that you've got. Okay. From this, I can find that that angle is 58.5. Okay. But again, that's not the angle I'm interested in. I'm going to go from this horizontal right here. Oops, not that line, this line. I know this line's 45. So basically I want to add 45 to that to get the total angle that I've got, which comes out to 103.5. So I didn't quite draw it. It's got to be a little bit more than 90 degrees, but you know, these are just sketches. The math is correct, okay? So don't break out a calculator or anything to get this. So my total answer is going to be 6.8 kilonewtons. And again, I draw this like this, where that angle is 103.5. And again, this, what I calculated that theta to be 58.5. Okay, added 45 to that so I could get it to the horizontal, which is a much more reasonable uh, value to base it off of. But again, I could have gone from the other side and got 86.5, or I guess that'd be 76.5. You know, that sort of thing. I could have gone from a vertical, got 13.5. There's lots of different ways to write this, but this is the way I've chosen to do it.